Neptune, the farthest planet from the Sun, and was the first to be predicted before it was discovered. Neptune is the 8th planet from the Sun in our solar system. This blue gas giant is far larger than Earth, at more than 17 times Earth's mass and nearly 58 times Earth's volume. Neptune's rocky core is surrounded by a slushy fluid mix of water, ammonia, and methane ice. Astronomer Galileo Galilei was one of the first people to identify Neptune as a space object. However, he assumed it was a star based on its slow movement. So far, most of the James Webb Space Telescope's images have revealed infrared views of deep sky objects like galaxies and nebulae. The James Webb Space Telescope has turned its gaze away from the deep universe towards our home solar system, capturing an image of a luminous Neptune and its delicate, dusty rings in detail not seen in decades. The last time astronomers had such a clear view of the farthest planet from the Sun was when NASA's Voyager 2 became the first and only space probe to fly past the ice giant for just a few hours in 1989. An international group of scientists announced the discovery of a Neptune-like exoplanet, 90 light-years away from Earth, that might have water clouds. This discovery marks an exciting step in a new era exoplanet research. The exoplanet, located outside of Earth's solar system, is called TOI 1231b. Both Neptune and TOI 1231b hold a resemblance with one another with their gaseous states and rich atmospheres. This exoplanet orbits a red dwarf star every 24 Earth days. This red dwarf star is smaller, dimmer, and less dense than Earth's Sun, but it's much older. The exoplanet's mass is 15.4 times larger than Earth. Despite closely orbiting its star, TOI 1231b is colder than other exoplanets at an average 134 degrees Fahrenheit or 56.6 degrees Celsius. It's considered one of the coldest and smallest exoplanets discovered so far. Even though TOI 1231b is 8 times closer to its star than the Earth is to the Sun, its temperature is similar to Earth's, thanks to its cooler and less bright host star. Cold planets occasionally have clouds high in their atmospheres. By comparing TOI 1231 with other exoplanets similar in size and temperature, scientists can infer whether water clouds are present or not. TOI 1231b is one of the only other planets we know of in a similar size and temperature range. So future observations of this new planet will let us determine just how common it is for water clouds to form around these temperate worlds. With the Hubble and Webb telescopes, scientists will be able to use transmission spectroscopy to capture star light emitted from TOI 1231b through its atmosphere. When the molecules in the atmosphere absorb the light, they show up as dark lines that can be read as a barcode and inform scientists about gases in the atmosphere. One of the most intriguing results of the last 2 decades of exoplanet science is that, thus far, none of the new planetary systems we've discovered look anything like our own solar system. Earth is our home, which makes it special in its own right. But there could be countless more like it waiting to be found or even born. The ongoing hunt for Earth-like worlds, especially over the next few decades, hopes to illuminate how ordinary and extraordinary our planet may be. Though there are some basic requirements for a world to be considered Earth-like, overall, it's difficult to narrow down a definition. We know that mass is key when it comes to identifying Earth-like worlds. Some research suggests that objects just 1.6 times the size of Earth are more likely to be gaseous, making them less similar to our planet. Mass is critical to spotting worlds like ours, but there are other factors to consider, such as a star's habitable zone, the not too hot, not too cold region where liquid water can exist on a planet's surface. There's something deeply humbling in looking to far-flung worlds for something shared with our own. It takes a lot of precise circumstances for a planet like ours to exist. The idea that this exactness could repeat itself doesn't subtract from how special Earth is. It amplifies the possibility that life can thrive somewhere else.